Remember, we have solved for x, like x plus 4 equals 20. I don't know why it's not writing neatly. Okay, so x plus 4 equals 20. What do we do to get our x alone?
You add -4.
I add a -4 to both sides. Because I'm getting rid of my 4 on this side. I'm using the inverse property of addition to make a 0. I have x equals 16. What do I have to do after I solve for x? I have to check it. So I'm going to throw my check in. Start with my original problem of x plus 4 equals 20. Put my 16 in that I just solved for. 16 plus 4 is 20. And does 20 equal 20? Yes. Check. Okay. Now, that's easy enough. But guess what? We have to do it with fractions. So this week's work looks like x plus 2.5 equals 5 1/7. How do I get x alone? Robbie, how do I get x alone?
What I do is I separate the 2.5.
Okay.
So it's x plus 2 plus 1/2.
Okay. X plus 2 plus a half equals 5 plus a 7th?
Yeah.
Okay, now what?
And then, so we have to take it earlier, so we have to add the opposite of 1/2.
Okay, so I'm going to add a -1/2 to both sides.
And then we have to find the least common multiple.
Okay, well, so tell me what I'm left with. This makes a 0 pair, so what am I left with on the left?
X plus 2
X plus 2.
equals 5 plus...
And so now you want to find a common denominator? So I'm going to come over and I'm going to do my work on the other side. Just on the side of my paper. Okay, so I can get an answer and throw it in right here. So I need a common denominator. What am I going to use? 14. And 1/7 becomes how many 14ths?
2 14.
Okay. And 1/2 becomes how many 14ths?
7 14.
7 14ths. Don't forget the negative. Okay, now what do I get?
Together I get 5 14.
Negative
Negative
5 14ths. And I'm going to plug that in. Okay. Now what would you like to do?
You add the opposite of 2.
Okay. So I'm adding a -2 to both sides.
And you get x equals 3 plus -5 14ths.
Good?
And then have to add them. So x equals 2.
Am I really adding?
No,
I'm really subtracting.
Yeah.
So how do we subtract? We got a whole number and we got a fraction. What do I really have to do?
put the whole number into a fraction.
Okay, so I got 3 plus that -5 14ths. So what do you want the 3 to be?
36.
So you have two options. You can change it. You can like borrow from a whole and make it a 2 wholes and 14 14ths. Or you could change the whole thing into something over 14. Which would you like?
2 wholes and 14.
All right, so let's do 2 wholes and 14 14ths. Because this is a 1 and this is a 2, so it makes a 3 because they're being added together. Plus that -5 14ths. So you have your 2 wholes, and then you have 14 plus a -5, which makes a 9 14ths. And so x is equal to 2 and 9 14ths. What do I have to do? Check. Okay, you ready to check it? Okay, I need a new sheet of paper, so you guys have to remember my original problem for me. Here's our check. What was the original problem? X plus
2.5 equals 5 1/7.
and my x value that we had solved for was
2 and 9 14.
2 and 9 14ths. Okay, so let's plug it back in. 2 and 9 14ths plus 2 1/2 equals 5 1/7. Okay, we have to prove that. So we have to solve this left side of the equation to see if it equals 5 1/7.
What I would do is make the 1/2 something 14.
Okay, so you want a common denominator of 14. So leave this one the same and change this one to a 14.
Yeah.
What's my numerator going to be?
7.
A 7. So now I have, so if, remember, you can break these guys apart to make it easier to see. You can break them into the whole numbers and the fractions that are just all being added together. And now you can use the commutative property of addition, and you can say my whole plus my whole. 2 plus 2 is 4. Plus, now I have 9 plus 7, which is 16 fourteenths. But 16 fourteenths is really an improper fraction, right? So we have to do something with him. So what is 16 fourteenths? It's really 1 whole and 2 fourteenths. So now I have some more wholes to add together. 4 plus 1 is 5, plus that 2 fourteenths. But 2 fourteenths can be reduced to 1/7. So 5 1/7 is equal to, and look, if I bring down what I started with, there it is. Did it work? Yeah, that means we got the right answer. Okay, but you have to walk yourself through the check to make sure. All right, let's try another one. We're going to try a multiplication one. Okay, so when we first started, we had things like 2x equals 20. Tatiana, what do I do to get my x alone?
You have to isolate the variable.
How? What am I going to do?
You're going to do
Read this to me.
2x equals
Okay, 2x. You're missing the property, what I'm doing, the operation.
2 times
2 times x. So what's the opposite of times? Division. So what am I going to do to get my x alone?
2 divided by
Not negative. Just divide by this number. Because what you're saying is 2 divided by 2 makes 1. And now I have 1x. So I have 1x. And that's what I want, right? I want an x. And I don't have to write the 1. I can just write it as an x. Okay? So if I divide by 2 on one side, I have to divide by 2 on the other, and I end up with x equals 10. And then, of course, I always check my answers, right? Okay? I'm not going to check it. This one's really easy to check. But now I'm going to do it with a fraction. Okay? Because this week is not whole numbers, it's not integers, it's fractions. So instead of 2 times x, we have 2 1/8 x equals 7 2/5. What am I going to do? Avani, what do you think?
Divide 2 1/8 x by 2 1/8.
Okay. Because no matter what, this is just a number, right? When it was a 2, we divided by 2. So just because it's a fraction doesn't mean we do it any differently. We still divide. Anything divided by itself is 1. So I'm left with an x. Okay, that made a 1. So if I do it to one side, I have to do it to the other side. Now that's where it gets a little crazy. Do we do anything that looks like that in math, really? Not really. So do we ever really work with mixed numbers?
No.
Not with multiplication and division. What do we do to them? Improper fraction. So I want to change the 7 2/5 to an improper fraction. What is it? What do you think, Vanessa?
You have to multiply the 5 and the 7 and add the
So what do I get?
You get 37.
37 what?
37 fifths.
37 fifths is my numerator. Divided by, what's my denominator, Julian?
Your denominator,
Owen, you're not writing anything down, which is our agreement.
17/8.
17/8. All right, now I got a fraction divided by a fraction. Do I really divide fractions? No. So what do I really do?
You multiply the reciprocal.
Multiply by the reciprocal. So I'm going to rewrite this so I can see it just to make sure. I'm going to say this is 37 fifths divided by 17/8. But again, we don't divide by fractions. We multiply by the reciprocals. So 37/5 times the reciprocal is 8/17. Okay? Now what do? How do I multiply fractions?
Across.
Straight across. But I don't want to get big giant numbers if I can help it. So what do I want to look for? Equivalent forms of 1. Are there any?
No.
How do you know? How do I know there's nothing that can come out of this? What do you think, Connor?
Nothing could go into 17.
Why?
Because it's
What's the word?
prime.
It's a prime number. What about 37?
Prime.
It's prime. What about 5?
Prime.
Prime. So guess what? We're stuck multiplying the big giant numbers. Find the answer. Go. Find the answer, Megan. What'd you get?
I got 296 over 85.
If you want to start, there's a little bit of filing. I don't want you to have her answer. I actually want you to solve it. I actually want you to practice the multiplication. Maybe Megan made a mistake. Robbie.
I got 296 over 75.
Uh-oh. What'd you get, Monica?
I got 296 over 85.
Uh-oh. We got 2 for 85, 1 for 75. Who else has an answer?
I have 296 over
85.
85.
296
It's
over
85.
85.
All right, Robbie, you must have done something wrong. Forgot to carry a 1 or something.
Yeah, you forgot.
All right, so now guess what we have to do?
Check.
We have to check it. This is simplified. There's primes. You can't do anything with primes. So we're going to check it. So someone has to help me remember our number. So here's our check. Our original problem was what?
2 1/8 x
2 1/8 x,
equals 7 2/5.
2/5. And our x that we solved for was?
296 over 85.
Excellent. Go. Plug it in and check it. I'm going to hit pause. Okay, anyone need me to explain it? So when I took it to its primes, I didn't see that 17 went into 85. I just assumed it didn't because it didn't look like it would. So, and that was my mistake. But 85 is really 5 times 17. So you cancel out your 17s and you end up with a 5 in your denominator. You get 37 over 5 equals 37 over 5. Okay? All right. This is